Hello, everyone. This is a guide for using Registax in order to process planetary and lunar images. Registax is a pretty old software, but it's still fairly good. There are a couple of things you need to do first. And the first thing is you're going to want to download Registax. And because it's an older program, it's a little bit harder to download than modern programs. If you try clicking on the actual download thing, your browser will probably not let you download it because it's not a registered, verified developer. So what you want to do instead is right click and then save link as. And when you do this, it'll pop up a place asking you where you want to save it. And maybe you put it in downloads, right? I've already got a copy in here. But if you do that, it will warn you. So at the bottom here, let me get my spotlight. In the bottom here, it actually is asking you to throw away the file. It doesn't want you to download it. So what you have to do here is click the little arrow and click keep, and then it will download. It's a little bit hard to do on modern systems. Back in the day when Windows didn't have, verified developers, it didn't care. You're gonna have to do that with Registax and the update. So you want to install this, just run this program to install it. I've already got it installed on this PC, so I'm not going to run it. And then you're also going to want to install your update. So install the base program first, 6.1, and then install update 6.1.08. I'll have a link to Registax in the description, so you'll be able to find it pretty easily. I'll also have a link to the sample data that I'm having you use. So this sample data is some data I collected back in August. It is a video of Saturn. It is not a very good video of Saturn, but it is fine for what our purposes are. So you can see it's pretty shaky. It's like the resolution quality is not very good, but we're gonna get a pretty decent image out of this, so it's okay. You'll notice that the image isn't blurry. It's like it's not the sharpest image I've ever recorded, but it's also not, there's no wiggliness to the image. Saturn is jumping around a little bit, but if I pause at any frame, right, it still looks pretty good. And that's what you want. In the end, I do recommend that you be a little bit aggressive with throwing out bad frames. So what I normally tell students who are in the collection phase is if at least half of your video looks good, you're good to go. You can throw away up to half the video and still get a pretty decent image. So you're going to want to download this. If you click the guy up here to download, you'll be able to download this file. And when you do, you'll get this warning. Google can't scan it for viruses. It is just a video file. It's not a program. There's nothing on it. It's literally just an AVI, so you should be fine. Again, link to the data, to the sample data is in the description if you want to follow along with this video. So we've got Registax installed, and we've got our sample data downloaded. So we're going to open Registax. It looks like this. Not a super complicated looking program, super straightforward here. You're going to start by selecting data. So select, let me actually walk through this a little bit better, shall I? We're going to click the bit up here that says select, right? This giant orange button up on the left-hand side, upper left. You're going to want to find your data. I think I saved mine to the desktop. There it is. And then you open it. There's a loading bar for basically everything at the bottom. So if you're like wondering what's going on with your data down here, this little loading bar, that's going to be how you tell what's up. Registax will say, this image is a color image. What do you think? Do you want to process it in color? And we want to say yes. If you accidentally click no, there is a button here. You want to just make sure that that color box is checked. If you can't find Saturn, maybe your thing is too zoomed out, you'll just want to click show full image and it'll show you the entirety of your image. I took a pretty small image, so there's really no difference. It's not a big deal. I mentioned that you are trying to get the best data out of this. And down here, we have a rejection criteria. And I want to keep just the best 300 frames. So this is a 600 frame file. And you can walk through the frames. That's what this like bottom part is. You can step through and see like what does your data look like down here. And as you click through that data, as you look through it, you can see, what do my individual frames look like? And these frames, they look pretty good. Like they don't look pretty bad. You can tell that Saturn in every single frame. In a good chunk of them, you can see the Cassini division. That's the like gap between the rings. So we're going to keep that, and we're going to keep half the data. If your data looks really good, you can keep more than half the data. But I generally say, if your data looks pretty bad quality, keep at least half of it. So this is pretty good. We could actually probably keep upwards of 500 frames and still be good. I'm going to do 300. I just want to keep this pretty conservative in terms of like what we consider good. As you get better at this and as you take better images, you can bump that up to a higher number. But at the start, and especially when there are a lot of people, on our roof, you're going to have pretty weird data. Once you've got that, you're going to click this button up here that says set align points. And what this button is, there are several of them: set align points, align, and limit. Those are the steps that we're going to take in order to align our data. So we're going to click that set align points. And for me, it's set 1, but we need more than that. So what you're going to do is you're going to put your mouse over important parts of Saturn. So I'm going to put an align point there, and you just click and it adds those points. And basically what you're saying is, hey, these are important points. Maybe you want to track them. And so I'm just going to add a few here. And what Registax is going to do is it's going to try to find these points in all of our data. It's going to go through frame by frame and see if it can identify these points. So once you've got your align points set, you're going to want to click the giant button that says align. And there is a loading bar at the bottom down here. If your data is too big, if you used too much of the sensor or took too many frames, Registax will quit on you. It is, at least with the laptops that we have on campus, Registax will quit on you. If you're doing this on your personal laptop, it probably can leverage a little bit more RAM and you're a little bit safer. But I do not know if this is a program level error or just a computer thing. Once we've hit all our align, it will show us just the frames that it has picked. That's not true. It'll show the frames that it picks by highlighting it. And so these little boxes here, that's telling us where the alignment cut has been taken. Basically, it has aligned Saturn, so it shows up in the same position in all these boxes. It is only using 300 of the best data points when we hit this limit button. So this button at the top, limit, what that's going to do is that is going to impose the limitation that we set. It's going to say, all right, take those best 300 and get rid of the bad stuff. So we're going to hit limit. And if you've done this right, these lines should all be parallel if you've picked really good points. I've picked kind of not good points, but we're going to see what we get anyway. Sometimes, even if they're not perfectly parallel, you still get something pretty good. It has instead limited us to 138 frames. So if you reach this point and you don't like your result, you can go back to a line and start over again. It's not a big deal. Maybe instead, of 300, we go 400 frames and hit limit, and that's better. So it has figured out the 400 frames that works best for us. And these lines are the ones we're looking at. So there is a way to go back and redo the limit. If you do not like what your limitation sets, go back and figure it out. So this all looks good. These are roughly parallel. So that means that we've got something pretty good happening here. We're going to click stack. That's this giant button here. And when we click stack, it is now going to take all of those data frames that it picked out and it's going to stack them. So it's going to average them together into one image. And again, there's a loading bar at the bottom. This is the other place that Registax might quit on you. But generally, if you've gotten past the align and limit portion, you're generally fine here. There's all sorts of crazy stuff here. Like you can set all sorts of things. We're not going to worry about it. It's not a big deal. So this is our photo. And you might notice that this isn't a very good photo. We can still see like bands and zones, so that's good. And the Cassini division is there. You can see it in the image, but this could probably be a little bit better. And that's what the wavelet tab is for. So at the very end, what you want to do is you want to open this wavelet tab. And there are all sorts of things here to help you figure out what to do. I recommend for planetary imaging to use this stuff over on the left-hand side. That stuff is the wavelet function, and that's going to help us get a really good image. Generally, 1 and 6 you want to leave alone. 2 you want to pull up. 5 you want to pull up. And then 3 you want to pull pretty far up, pretty much about halfway. And 4 you want to do the same thing. I don't know why this works. I had a student who explained that this is a good thing to do for this type of image, and that was it. They didn't know why it works. They didn't know, you know, anything like that. So all they said was, you should do it. And so I did, and it looks good. I think it's a form of what is called deconvolution at different scale lengths, but honestly, I have no idea. I don't know how this works. I'm not going to pretend to know how it works. All I know is that if you put the wavelets in this configuration, you generally get a very good image. It sharpens the image in just the right way for planetary data. We also have a few things over here if you want to mess with the contrast and brightness. I'm not going to mess with the contrast and brightness, but just to show you what it does, if your image is dim, you can boost the brightness or bring it down if it's too bright. I actually think 0 brightness is perfect for this image, so I'm not going to adjust the brightness. If you want to bring out some of the features, make the darker parts darker and the brighter parts brighter, you can boost the contrast a little bit. Or if you want to wash out some of the features that are too bright, you could reduce the contrast. Again, I actually think 100 contrast is fine for this image. I don't think that we need to mess with that. So I'm not going to. I think this is fine. All right, now it's time to save our image. So before you save, you want to do all. Do all will add every single bit of processing that you've done. So right now is just showing you a preview. If you try to save this, it's going to actually show you everything before you applied those wavelets. So click do all, and that'll apply everything to the actual image. And then click save image. When you click save image, it's going to ask you to save it. JPEG is a good file type for if you are on campus and using campus computers and you want to email a copy to yourself. PNG is a little bit better. It is slightly higher quality, but it's also bigger. And since it's bigger, it's going to take you a while more to email it to yourself. A TIFF file is a pretty high quality file. If you plan to do any post-processing in Photoshop or GIMP, that's the file type you want. It's lossless, which means that it's not going to degrade quality when you save it. And FITS file is a type of file. It stands for Flexible Image Transport Format. It is a type of scientific file. So we don't need to use those for this type of thing. You need special programs to read it. And it's really good if you're doing science because you can add what's called a header to it. It's a bunch of text that just tells you what the image is about, where it was taken, how it was taken, what instruments were used, and what was used in the processing. We're going to just save this as a JPEG. So we're going to go ahead and save that. And that is pretty much it. If we wanted to take a look at this image, we're just going to pull up the JPEG that we just saved. And let me go ahead and share that screen. There we go. We just pull up the JPEG that we just saved, and look at that. We have an image of Saturn. Isn't it pretty? Anyway, that is the basics, right? Like, if you followed along, you should have a pretty good image of Saturn. You cannot use this for your you cannot use this particular data set for your own image of Saturn. Saturn does not look like this on the night that we observed. Saturn does have a slightly changing surface. And so because of that, it looks different every time you take a picture. I'll definitely be taking a look at your data to make sure that it is data that you took that night. So yeah, happy stacking. I hope that this was informative. And if you have any questions, do feel free to reach out. Registax is not super complicated software, but the first time you use it, the first couple times you use it, there are like little things that you got to watch out for. So I hope that this was a helpful video, and I will see you next time.